At the start of a new millennium, we're about to embark on the greatest adventure of all time. 500 million miles from Earth, a spacecraft will land on Jupiter's icy moon, Europa. Its mission? To search for alien life. As we reach out across the galaxy, our spacecraft will explore the most extreme environments to answer the ultimate question. Are we alone? Our universe is made up of countless galaxies, each teeming with billions of stars like our sun. Orbiting around them may be billions of planets. Any Earth-like planet could be home to an intelligent alien trying to communicate with us.
The Pentagon admitted just moments ago that a researcher at the SETI Institute in California has detected a radio signal from beyond the solar system.
Il segnale captato al Deep Space Network di Madrid sembra provenire da extraterrestri. Gli scienziati
首脑将在今天召开紧急会议，商讨是否需要宣布各国进入紧急状态。这次汇集世界
The signal was first detected at 3 a.m. this morning, and following confirmation from other radio telescope sites around the globe, the Pentagon announced that the extraterrestrial radio signal should be considered valid.
There are 400 billion stars in our Milky Way galaxy and billions of other galaxies as well. It would be bizarre if we were the only life.
We're discovering that life forms can exist in places and conditions that we couldn't have conceived of a few years ago.
Since a good proportion of stars seem to have planets, we might expect primitive life to be widespread in the universe.
Scientists from around the globe are being asked to verify the exact origin of the signal.
What if we get a signal? What will happen? Will you still go to work tomorrow, or will the world stop? It's the oldest unanswered question that our species has posed to itself. Is anybody else out there?
It's a question that Jill Tarter has been trying to answer for over 20 years at the SETI Institute, an agency dedicated to the search for extraterrestrial intelligence. All over the world, SETI researchers are more optimistic about picking up that first call from ET than ever before.
What's so terrific about now is the fact that we suddenly have the technology that allows scientists and engineers to try and answer this old question. For me, I can't imagine doing anything more important.
Set amongst the dense rainforests of Puerto Rico is the largest electronic ear on Earth. It's so sensitive it could pick up a mobile phone on Jupiter. The Arecibo radio dish is 1,000 feet across. Twice a year, the SETI researchers come to Arecibo to listen out for signals from deep space. "5,000 miles away across the Atlantic is the Lovell Dish at Jodrell Bank. This is the largest radio telescope in Britain.
The equipment we're using for this search is the most sophisticated that's ever been used. It's using two of the world's largest radio telescopes to make the most sensitive system that mankind has ever been able to use, or probably will be able to do, for 10 or 20 years in the future.
Together, these two dishes are targeting those distant stars most likely to be orbited by planets. They're trying to detect alien interstellar messages. But where on the radio dial will the extraterrestrials be broadcasting? The SETI Institute is currently scanning 28 million radio frequencies.
Talking about eavesdropping on aliens makes for easy dinner table conversation. In fact, doing it is quite hard. If you have 28 million channels, you can't just have 28 million guys with earphones awaiting the signal. You have to have very specialized computers that can look through all those channels at least once a second and make decisions about, is there something interesting in there?
Their computers isolate any unusual signals from the constant background radio noise that swamps the Earth from every corner of space. They're listening out for a special signal, one that suggests it's been sent by intelligent life.
You can imagine tuning the radio dial there and you'd hear this whoosh all across it due to natural noise sources. Not very interesting. But every now and again, you could imagine coming across a squeal. That squeal is called a narrowband signal, and that's exactly what we're looking for, because only a transmitter, something that's been fabricated, can make a signal that's narrowband.
The researchers have to make sure the signal really is coming from deep space. They must eliminate any transmissions from passing aircraft, satellite, or military radar. It's only by using two dishes so far apart that they can calculate if the signal originates from beyond our solar system. This method has already picked out one distant signal. Though this isn't from ET, it's from one of our own interstellar spacecraft. In 1972, Pioneer 10 was launched on an epic journey to the giant planet Jupiter. Its mission long since over, Pioneer is now billions of miles beyond our solar system, but its signal is still loud and clear.
Pioneer 10 serves as a test case for us. In fact, it's so far away that its signal looks like a signal coming from a distant star.
Every day, the American and the British teams tune into the Pioneer signal. It's the most distant message they've ever received, but the scientists hope for something far better.
Have we ever found a signal from space that was clearly due to extraterrestrial broadcasters? Well, the answer is no. I mean, I wouldn't be sitting here if the answer weren't no. I'd be relaxing on the Côte d'Azur having a drink, I'm sure. We haven't found them yet. So far, the aliens have been coy.
Jill Tarter and Seth Shostak have both dedicated their lives to listening out for a message they may never receive.
Every day when we go to the telescope, we have some sense of anticipation that we may, in fact, find the signal. We put champagne on ice in the refrigerator here and wherever we observe, because we do plan for success.
The cosmic odds are stacked in their favor and improving with every new astronomical discovery. There's no shortage of places a message might come from. Our own galaxy, the Milky Way, contains over 100 billion stars. If every one of those stars were a grain of salt, they would fill an Olympic-sized swimming pool. How many of these stars have planets that could be home to an alien intelligence? Until recently, we could only guess. But over the last 5 years, astronomers have made an extraordinary breakthrough. They've discovered over 20 planets outside our solar system, and they believe there may be literally billions more.
My guess would be that something like 50% of all the stars in our Milky Way galaxy, which itself contains 100 billion stars, probably something like 50% of them harbor planets.
Jeff Marcy is one of the world's most successful planet hunters. He and his colleagues have discovered more planets orbiting around other stars than orbit within our own solar system. Standing high on the summit of an extinct Hawaiian volcano, the giant Keck telescope is Marcy's most penetrating eye on the universe. In 1999, his team made their most startling discovery. This time, they found not just a single planet, but 3 worlds orbiting the same star, Upsilon Andromedae.
We have found now a complete system of planets, just like the system of planets we have around the sun. These are not isolated freak planets that we had been finding, but at least in this one case, we now realize there's a complete system that is very reminiscent of the ordering of the planets around our sun.
This new planetary system lies 320 million miles from Earth. The closest planet whirls round its star in just 4 days, the outermost in 4 years. So far, their equipment can only pick out the real heavyweights, planets the size of Jupiter. But the planet hunters are convinced there's greater treasure to be found.
There's almost no question that among the 100 billion stars in our Milky Way galaxy, there are not just the large planets that we've been finding, but of course smaller ones, probably indeed in greater numbers. And so Earth-like planets are out there.
NASA's proposed Kepler mission may provide the definitive proof of Earth-like planets. In the early part of the 21st century, this space telescope will continuously monitor 160,000 stars. Kepler's eagle eye will watch for any star that blinks, even when a planet as small as Earth passes in front of it. But if we do find an Earth-like planet, there's no guarantee it will be home to intelligent aliens. It may be too hot, too cold, or too poisonous for ET to survive. Or perhaps alien life may have evolved on planets where the conditions would be far too inhospitable for humans. To find out just how extreme an environment can be and still sustain life, NASA is researching the most hostile places on Earth.
Let's go.
Before we set out to look for life on other planets, this research will direct us where to look. NASA scientist Tony Phillips is searching for primitive life in one of the coldest places in North America, high in the eastern Sierras.
Right now, we're at the White Mountain summit. We're at an altitude of over 14,000 feet. The pressure here is very low. During the wintertime, the temperature here is comparable to the temperature at the South Pole during the South Polar summer. So the environment is very extreme. Not much lives here, but we suspect that there may be microorganisms living in the soil or living in the permafrost beneath the layer of rock, and no one knows whether they do or not, but that's what we're trying to find out.
Hike, Tovik, hike! Whoa, 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 hang on, guys.
The NASA scientists have discovered that life can survive in places where no one had expected. It now turns out that life can survive just about anywhere that there is water. It doesn't seem to matter how hostile the environment is. At Yellowstone Hot Springs in Wyoming, Dave D. Murray has proved that microbial life can even survive in boiling water, an extreme environment that we never thought possible before.
The limits for life are much broader than we had previously suspected. We've now discovered that life can exist up to 113 degrees centigrade, a higher temperature than we had dreamed about 20 years ago. But we find that that is actually a very nice place for certain organisms to live.
If life can survive at these temperatures, perhaps it can live anywhere. Mono Lake in California is one of the most hostile environments on Earth. Its scenic beauty is deceptive. The lake is so loaded with salt that it's poisonous to us. Jack Farmer has discovered that even here, life can find a way.
In Mono Lake, the salinity of the water here is 2.5 to 3 times seawater. In addition, the pH of the water here is around 10.5, very alkaline. And yet, that's not a barrier to life. Organisms are thriving here.
The lake is teeming with microbial life.
In the last decade or so, we've begun to realize that it's really a microbial world. This world that we live in is dominated by microorganisms. We've come to realize that microbial life can occupy a whole range of environments that we never thought possible before.
The tenacity of life here in Earth's most extreme environments encourages many biologists to believe that life may be remarkably widespread throughout the universe.
I think the chances of finding life elsewhere in our solar system are pretty good. Sometimes I say, well, maybe 50-50, but I have to be honest, I don't really know how to put a probability on it. But I think anywhere where we had liquid water and the right organic compounds present, we've certainly had more than enough time to originate biological systems. The probability is probably pretty good.
For most of Earth's history, the only living things were microbes. As they search the universe, scientists expect to find planets crawling with microbial life long before they find one with intelligent life. Instead of meeting little green men, they're much more likely to meet little green slime. Our quest to discover life on other worlds began optimistically in the 1960s when a flotilla of spacecraft headed for our neighboring planet, Mars. But their cameras revealed only craters and extinct volcanoes. Mars seemed a barren and lifeless world. This gloomy assessment was reinforced in 1976 when 2 Viking craft landed on the rocky Martian surface. They scooped up soil samples and analyzed them for any signs of microbial life. The results were negative. Mars seems extremely hostile to life. The average temperature is minus 53 degrees Celsius, and the thin atmosphere provides no barrier to the sun's deadly ultraviolet rays. Even the rocks contain chemicals that can destroy living cells. But the idea of finding life on Mars continues to obsess many scientists. When Bruce Joukowsky started his research career, Viking had just landed.
Viking went, it looked for life, it found none. And there was a real sense that there must be only one planet in our solar system that could support life, and that was the Earth. Things have changed dramatically since then, in particular, the revolutions in terrestrial biology and the possibility that life could have originated in some of these extreme environments.
Close-up pictures of the red planet have revealed tantalizing evidence that water once flowed across the surface of Mars.
We see clear geological evidence that there's been water on Mars. On some of the older surfaces, we see networks of valleys that look like river tributary systems where waters flowed through them and carved these long channels. The availability of water at the surface or in the crust really, I think, is what makes it possible for life to be there.
The evidence came sooner than expected. On August the 7th, 1996, NASA called an unprecedented news conference. These scientists had examined a meteorite that had come from Mars and discovered something very strange lurking inside. One of the microbiologists on the team was Dave McKay.
We have a number of forms which it is very tempting for us to interpret as Martian microfossils.
The NASA team had been alerted by chemical residues in the rock that here on Earth can only be made by microbes. Then they picked out strange worm-like structures that looked like tiny fossilized life forms. It all began with a unique discovery on the snowy wastes of Antarctica. Each year, a meteorite survey team meteorites fall all over the Earth, but here the small dark rocks are easy to spot on the pure white ice. In 1984, the team picked up one meteorite, ALH 84001, that was to completely change our view of life in the universe. It wasn't until 9 years later that researchers discovered that the survey team had brought back a lump of Mars, a rock formed 4.5 billion years ago. Its origin was proved by traces of gas which exactly matched the composition of the Martian atmosphere measured by the Viking landers.
This is an incredibly complex rock. It's much more complex than we first realized. It's more complex than most Earth rocks that people study. And this rock has been studied more than any rock in the history of the world.
Some scientists believe the microscopic structures are natural crystals. But for McKay, the case for Martian life grows ever stronger.
These are fossils of little tiny bacteria, single-cell organisms. They're not bones. They're little tiny cells that have turned to minerals. They're fossilized, but they look exactly like fossils from Earth rocks.
But the only way to find out for certain if there's ever been life on Mars is to go there and collect a sample. NASA missions in 2003 and 2005 will collect rocks from the Red Planet and then return them to Earth, where they'll be dissected for fossils. The surface of Mars is the same area as all the continents of Earth combined. There's an enormous choice of possible sites when it comes to collecting the priceless samples. Mojave Desert in California is one of the most inhospitable places on Earth. This dry lake bed was once covered in water. Its parched surface is the perfect place for Chris McKay to research where NASA should collect its first samples in order to look for fossils of microbes that once lived on Mars.
This lake bed is the sort of place we'd be looking for on Mars, as a place to search for evidence of past life. It's a nice, big, easy-to-find target, easy to land in, easy to drive around on, easy to drill in. If there had been water in a lake like this on Mars, anything living in it, as it died, would settle to the bottom and we'd be able to find it in the sediments. Here in the Mojave Desert, we might dig under the surface and find evidence of life that's just a few years old. But on Mars, these sediments would be 3.5 to 4 billion years old, and we'd be looking for evidence of life that was on that planet when it was more like the Earth, when it had water. Here in this desert, we find, growing just underneath the surface of certain rocks, microorganisms, algae. These organisms grow under the rocks because the rocks trap a little bit of moisture, so it's not quite as dry. But they have to grow under the white stones because enough light can get through the white stones so they can photosynthesize.
This precarious existence could have been the way that life on Mars survived for billions of years.
Who would have been the last organism to live on Mars? Maybe an organism living underneath a rock. Maybe when we go to Mars, we'll search for relics, for fossils of this type of life.
But perhaps the search will turn up much more than just fossils. Despite the barren landscape, some biologists are now uttering what was for many years a heresy, that microbes may still be living on Mars today. Microbiologist Todd Stevens has discovered that deep underground in Washington state, life is flourishing in apparently solid rock. Until the mid-1980s, most people thought that the deepest you could dig down into the ground and find living organisms was around 30 feet. But Stevens has discovered that life on Earth can thrive as deep as 2 miles down. The Columbia River area of Washington state is covered in ancient lava flows thousands of feet thick. At the edge of a river gorge where the lava flows are exposed, Stevens has discovered how tiny microorganisms can live in solid rock.
Here at the bottom of the canyon, we can kind of get an idea of what their habitat looks like. Here we have the intersection between 2 basalt flows, and at one time water has flowed through this layer over tens of thousands of years, and microorganisms live here. Well, this is exciting because if this is correct, this is a way that living organisms can live in places where the surface of the planet is not habitable.
On Mars, any microbes living deep in the rock would be well protected from the hostile surface environment. Stevens was researching the safe disposal of nuclear waste when he made his startling discovery about life deep underground.
This one has to be several hundred meters deep.
He took water samples here from boreholes that were drilled 2 miles down through the volcanic rock.
When we sampled the water that was coming out of the deep aquifers in this volcanic rock, we were kind of surprised to find that each liter of water contained between 1 million and 100 million microbial cells. And we know that the vast majority are actually attached to the rock, so there's many more than that down there.
To prove they could survive without sunlight, Stevens bred the microbes in his laboratory, simulating their subterranean world. His results confirmed life's amazing ability to live anywhere there's water. These bacteria, stained red, feed off hydrogen gas, created when water reacts with the volcanic rock. Even more exciting, these bacteria bear striking resemblance to the apparent fossils found in the Mars meteorite. Perhaps the descendants of these fossilized microbes are still living deep under the Martian surface. The temperature on Mars is well below freezing. Any life near the surface would be frozen solid. Astrophysicist Richard Hoover has made the astonishing discovery that microbial life can be reanimated even after it's been frozen for thousands of years. The Fox Tunnel in Alaska is one of the coldest places on Earth. It was originally excavated for gold mining and dug out of the permafrost, where even the soil 150 feet below the surface is frozen solid.
We have found microorganisms in the permafrost of Earth that are alive, and yet they have been frozen for up to 3 million years. Therefore, it is possible that there may be microorganisms frozen in the permafrost of Mars.
By warming samples from the permafrost, Hoover can revive these dormant organisms. It's not just microbes that wake up when the temperature rises. Even plants like moss can be brought back to life.
I have here a moss that was frozen in the permafrost for 40,000 years, and after it was extracted from the permafrost, the moss started to grow. It realized that the weather had gotten better and it was time to grow again.
As they're warmed up, any samples of life collected from Mars by NASA may also be revived. Returning a piece of Mars to Earth will require the strictest quarantine. It may be the most risky venture the human race has ever undertaken. No one knows what might happen if Martian bugs were released onto our planet.
If there's life on Mars, we have to be cautious because that life is not understood. And as we know, microbial life can be quite dangerous. Both viruses and bacteria can be dangerous to humans. It can also hurt the environment.
Unlike the meteorites, which have been sterilized by natural radiation as they travel through space, these rocks will have been transported directly from Mars.
They will be treated as if they might have an incredibly dangerous microbe in them. We don't know that, we don't think that'll be true, but we can't afford to take the chance.
4, 3, 2, 1. We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
In 1989, Space Shuttle Atlantis set off on a mission that may lead us to the first definitive discovery of life beyond our own planet. On board was the unmanned Galileo spacecraft, bound for the king of the planets, Jupiter. In this remote frozen region, 500 million miles from the sun, the last thing the mission scientists were expecting to find was signs of life. Giant Jupiter is big enough to swallow the Earth 1,000 times over. Its family of moons forms a miniature solar system. The four biggest are Io, Ganymede, Callisto, and Europa. Brilliant white Europa is completely covered in ice, its surface crisscrossed by strange grooves. Many scientists now believe that this frozen world is the most likely place in our solar system to be harboring extraterrestrial life. The nearest equivalent to the surface of Europa are the glaciers of the Arctic.
The microorganisms that are found in the glaciers and in the polar ice caps give us a good model for the types of microorganisms that might be found someday when we bring back samples from Europa. I become very excited when I look at the beautiful pictures of Galileo of the surface of Europa because we see magnificent colors. And those colors are very similar to colors that we see in bacteria and algae on Earth due to the pigments of these microorganisms. When we do get samples back, we will have a good idea of what types of things to look for, and we will have the ability to recognize the microorganisms when we find them.
The microbes of Europa would have to be far tougher than their Arctic counterparts. They'd have to survive lethal doses of radiation generated by Jupiter's powerful magnetism.
We know that there are microorganisms on Earth that have evolved to have the ability to withstand intense levels of radiation. There are bacteria that grow on the cooling rods of nuclear reactors. And if, in fact, organisms live on Europa, then they would have had the ability to adapt to these high radiation levels. So we must always be cautious about saying that life cannot do things, because quite frequently we find that life does exactly what we think it's not capable of doing.
The cracked ice surface may suggest something even more exciting. Heat from the core of the moon may have melted the ice from below. Just like the cracked Arctic ice sheet on Earth, Europa's icy surface may overlie a huge ocean of water.
All life as we know it utterly depends on liquid water. Europa may be the only other place in the solar system where there's an ocean of water, and that means it's the most exciting place to go and look for life elsewhere.
Beneath the icy crust of Europa could lie an ocean as deep as 60 miles. This cold, dark environment seems a fruitless place to look for living organisms. But the depths of the Earth's oceans prove that life can once again flourish in the most unexpected places. In the 1970s, the lights and cameras of deep-diving submersibles discovered vents erupting hot water from the ocean floor. where no sunlight ever penetrates and the surrounding water verges on freezing, these volcanic vents support the most exotic life forms on Earth.
It's certainly possible that those sorts of hydrothermal vents exist on Europa. There may well be teeming communities of organisms at hydrothermal vents at the very bottom of Europa's oceans. Now, on Europa, that's 100 kilometers down. The oceans on Europa are much deeper than they are on Earth, so those are not going to be easy to reach and investigate.
Around 2010, NASA plans to send its most ambitious unmanned mission ever. Touching down where scientists suspect the ice is thinnest, the Europa lander will lower a probe that melts down through several miles of ice. A second probe, a hydrobot, will swim down to the bottom of the ocean. As it descends, it will transmit live pictures back to Earth. The hydrobot will be programmed to seek out hydrothermal vents, the most likely place to find life. This will be the most alien environment we have ever explored. Will it be teeming with tiny microbes? Or perhaps home to fully developed alien creatures? Even if we do discover life in our solar system, scientists believe that it will be fairly primitive. If we want to find complex life forms like us, we'll have to look far beyond our neighboring planets.
If we want to think about intelligent life, we need to look past our solar system. We need to look at the possibility of Earth-like planets orbiting other stars and whether life might have originated there. And then we need to think about communicating with them.
Any nearby aliens would already know that we are here. For the last 75 years, Earth has been leaking radio and television transmissions out into space.
Tracking the sound barrier.
Our broadcasts reach the nearest stars 4 years after they are transmitted on Earth.
Eagle has landed. Marilyn Monroe was found dead under circumstances that were in tragic.
Our oldest signals, broadcast in the 1920s, have traveled past 100,000 stars in our galaxy.
The Hindenburg horrible end has shocked the entire world. The pride of the skies reaches its
Beyond this point, 75 light years from Earth, no one would have any idea of our existence. Alien civilizations may be far older than the human race. Dan Wertheimer is pioneering a completely new approach to intercepting their interstellar messages.
We don't really know what other civilizations are going to be doing, so we ought to try a lot of different strategies and not put all our eggs in one basket. Perhaps other civilizations, instead of sending us radio waves, are sending us light waves, perhaps from very bright lasers.
Wertheimer is hoping to intercept laser-like messages that extraterrestrials are beaming across the universe. On Earth, we can produce laser light signals 1 million times brighter than our sun. We have already transmitted our own laser beams to the moon and back. If we can do it, Wertheimer believes that ET can do it even better. Here at the Leuschner Observatory in California, his telescope is linked to a high-speed computer that's searching for a spike of a pure color of light, the telltale signature of a laser. Over the next few years, this telescope will scan 2,500 stars.
We're looking for a very bright pulse. It would only be on for perhaps a billionth of a second. It's like looking for the kind of flash that you'd see from a lighthouse. As the beam comes around, you'd see a sharp pulse, very bright, and then it would go off for a while, but then you might see it again.
Hidden in these short pulses could be a whole encyclopedia of information, coded like our own computers.
If they send us a signal intentionally, it's likely that they will make it easy for us to understand that message. It will have language lessons, lots of pictures, vocabulary lessons, and then they would send us a huge amount of information, all their music, their poetry, their literature, their science, their medicine. That would be an amazing feat.
It's an opinion that may be naive. The aliens could turn out to be worse than any science fiction nightmare.
I think it would be a disaster. The extraterrestrials would probably be far in advance of us.
Astrophysicist Stephen Hawking believes that not all aliens will be friendly. We should take heed of past experiences on Earth.
The history of advanced races meeting more primitive people on this planet is not very happy, and they were the same species. I think we should keep our heads low.
I don't think that other civilizations are going to come and eat us. There are not that many raw materials on Earth. There are much bigger planets, and also I suspect that advanced civilizations are not killing each other the way we are.
But even if they are aggressive, the sheer size of the universe makes it unlikely that we will meet an extraterrestrial in person.
Imagine yourself as one of the crew of this faster-than-light spaceship of the future.
Hollywood and science fiction try to convince us that it's easy to travel to the stars faster than the speed of light. So far, the fastest we can manage in our current spacecraft is 40,000 miles per hour. At this rate, it would take 70,000 years to reach even the nearest stars. The only realistic way to make contact is to eavesdrop on alien signals. And we may be communicating with aliens sooner than we think.
I'm optimistic in the long run. Probably in our lifetimes, maybe 50 or 100 years, we will be in contact with other civilizations.
If we did find a signal, it's bound to have a fantastic effect on our human civilization. I don't think there'd be any worry or any panic, but we would know for the first time that other life exists.
We may find out that we are just one of many civilizations in the universe. Or we may find out, in the end, that we are extremely unique. So maybe we're alone, maybe we're not. Either way, the answer is really significant.